sometimes probabilities differ based on other variables, not just on the values itself. For example, in the Titanic dataset, we might be interested in whether or not somebody survived. Yes means they survived, no means they didn't, based on what class they are in. Okay. So for example, our probability of surviving overall is 711 here out of 2,201, which gives us a value of about 1 in 3. What we're interested though is in the conditional probability, which is the probability of something given something else. So first we might be interested in the probability of surviving given that you're in first class. So we're going to limit ourselves down to just this first class row and calculate our probability as 203 divided by 325, about 2 in 3. Note that this vertical bar is the mathematical notation for the phrase given that. It means we're going to limit ourselves to just that row. In contrast, we might be interested in the probability of surviving given that you're in the crew. Here we take our 212 divided by 885 and get a value of 0.24. If we want to do this formally, we can say that our probability of surviving given that we're in the crew is the probability of surviving and being in the crew. So that's yes and crew, divided by the probability of being in the crew. While this seems to give us exactly the same information, the reason it's different is that often instead of count data, you will be given probabilities directly. This is particularly true when we're talking about independence. Informally, independence is just unrelated events. Formally, this can be defined as the probability of B does not depend on whether or not A occurred. So if we look back to our previous thing here, we see that our probability of surviving depends on whether we are in first class, crew, or a different class altogether. This means that these events are not independent and leads to some other implications that we'll need to handle in a moment.